Hello, this is the 8th in a series of videos about learning to program using PowerShell. These videos are aimed at new programmers or non-programmers who want to learn to code, and they build on each other, so if you haven't already, you might want to check out the link in the description to watch from the beginning. So in this video, we're going to learn about PowerShell modules, and we're going to create our own PowerShell module. We're also going to learn about objects and a little bit more about objects and classes. So a PowerShell module is just a grouping of functions and other code and sometimes data in one unit that has a name. And a lot of PowerShell modules are what are called binary modules. They're implemented as DLLs that are written in some compiled language like C# or C++. And many applications and system components have PowerShell modules associated with them to enable you to automate some of their functionality, like things like Hyper-V and Active Directory and VMware. A lot of these things have PowerShell modules. So that's one of the things that makes PowerShell so useful for IT professionals. That's not really my area, so I don't know if I'm going to be talking about that, not today anyway. But you can also implement your own PowerShell modules in PowerShell itself. And that's what I'm going to do in this video. So we're going to create a, wrong direction. So we're going to create a script module implemented in PowerShell itself. It's called primes.psm1. And just like a PowerShell script has a .ps1 extension, a PowerShell script module has a psm1 extension. And in our module, we're going to create a couple of exported functions that we can call. And they're both related to primes. We'll have one that just gets prime numbers up to a certain number, and one that factors a number into its prime factors. And along the way, we're going to learn some new concepts. One of the things is that the getPrimes function is going to implement an algorithm called the Sieve of Eratosthenes. So we're going to learn a little bit about just that algorithm, which is just a fairly simple one, but it's a nice example of how to implement an algorithm in PowerShell. Along the way, in order to implement that, we're going to use a couple of nested for loops. So this is a for loop within a for loop, and so we'll walk through that. We're also going to learn more about objects. We're going to create an object as part of that algorithm, and later we're going to create an object of our own type that is implemented as a PowerShell class. So there's a whole lot to cover here. We might as well get started. The Sieve of Eratosthenes is an ancient algorithm for finding all the prime numbers up to some certain maximum. It was discovered by an ancient Greek mathematician, and it's a simple algorithm that can be executed on pen and paper, but it can also be executed on a computer. Algorithm is just a fancy name for a method of doing something. When you learn how to do long multiplication or long division or adding decimal numbers with carrying the digits over, you're actually learning an algorithm for how to do that. So this is an algorithm for finding prime numbers. So the way it works is we simply use a process of elimination. So we start off, we can eliminate 1 because that's not prime. We start with the number 2, and we circle that because 2 is the first prime number. But then we can eliminate all the multiples of 2. So we simply count upward by 2s. We cross off the 4, the 6, the 8, the 10, the 12, 14, 16, 18, 20, 22, and 24, and on up to however far we're going. Once we've done that, we go back, pick up where we left off. We're on 2. We advance to the next number, which is 3. Well, 3 has not been crossed off, so 3 must be prime, so we can circle that. Now we go through and we cross off all the multiples of 3. So we advance from where we are up to the end of the sequence by 3s. So 6 is already crossed off. We can cross off 9. 12 is already crossed off, but we can cross off 15. 18 is already crossed off, but we can cross off 21. And 24 is already crossed off, and then we're at the end. So we've done with 3. Now we move on to the next number, which is 4. That's already crossed off. So it's already been eliminated. It's not a prime, so we could just skip it. Then we go on to 5. Well, that's not been crossed off, so that's a prime. Now we go through and we cross off all the multiples of 5. The only one we haven't already gotten is 25. Then we go past, from 5, we go on to 6, which is already crossed off. Then 7, that's not that's not crossed off, so that's prime. So now we can cross off all the multiples of 7. So there's 14 is already crossed off, 21, and we're done with that. Then we move on. We can skip over 8, 9, 10 because they're already crossed off. We get to 11, so that's prime. So we cross off the multiples of 11, which we have 22 is already crossed off. So we pick up where we left off. We've got 12, 13, that's prime. So then there are no multiples of 13. The 26 is beyond the end of our sequence, so we can continue on. 14, 15, 16 are already crossed off. 17. So we would go through and cross off multiples of 17, which we don't have any more. Can skip over the 18, circle the 19, skip over 20, 21, 22, and 23 is prime, and so on. And then we've reached the end of our array. So we found all the primes up through 25. So all we need in order to implement this algorithm is some method of keeping track of which numbers are crossed off. We need to know what our current number, we need to know what the maximum number is. The inputs to the algorithm is just the maximum prime we're looking for, the maximum number we're looking for, in this case 25. And then what we need in order to keep track of sort of the state of our algorithm is some method of crossing off numbers that we've eliminated. So in order to implement this in PowerShell, what we need is, the main thing we need is this method of crossing off numbers that we've eliminated. So we need some sort of array that contains some sort of state that corresponds to our piece of paper. So in our pencil and paper version, we had a piece of paper with all the numbers listed, and we just crossed off the ones that were not prime. In our PowerShell implementation, we're going to have some object in the computer where we have one element for each number, and we need to be able to store some kind of state, and the only state we really need to know is whether it's crossed off or not. So that seems like something that's a job for a Boolean. So for each number we could just store a Boolean value. Either it's been crossed off, in which case it's true, or it hasn't been crossed off, in which case it's false. So we could just use an array of Boolean values, and the index into the array would just be the number. So in this case, for example, where we have the numbers 1 through 25, we could just have an array of 25 Boolean values. Or it would be more convenient, since we're using zero-based indices, to have an array of 26 Boolean values, and we cross off the ones that we're interested in. Then we're going to have a for loop that takes us through the whole sequence. We just execute once, starting at 2 and all the way up to the end. And then within each iteration of that for loop, we're going to have another for loop to scan ahead to cross off the multiples. So let's go ahead and get started with implementing our algorithm. So I'm going to bring up a PowerShell terminal window here. And we're going to create a PowerShell module. So I'm already in my Learn PS directory. So I'm going to invoke Visual Studio Code, and I'm going to give the name of the module I want to create. So I'm going to call it primes.psm1. And again, like I said in the introduction, a PowerShell module, script module, has to have a PSM1 extension. So I do that. Visual Studio Code loads up. It's going to create the file for me. And now I have a module. So let's go ahead and let's just write a function called getPrimes. GetPrimes. And I'm going to have a parameter. I'm going to declare its type as integer, and I'll call it max value. So this function is going to return all the primes less than or equal to max value. And just to have some sort of before we even actually implement the algorithm properly, let's just output 2, 3, 5, and 7. Okay, just to demonstrate how we can call this function. So the next thing is, so let's go back to our PowerShell prompt. And before we can actually use a PowerShell module, we need to actually load the module or import the module. So we can use the import module commandlet, and we just give the name of the file. Primes, hit tab to autocomplete, and there's our module. So if I say get primes, oh, Oh, it actually found it. There it is. Get primes. 2, 3, 5, and 7. So it output the numbers that we specified. Now what if we add 2, 3, 5, 7, 11? And then we say get primes. Oh, it still did the old version. Well, the reason for that is when I said import module, it loaded that module into memory, and even though I've modified the file, I'm still actually, when I call the function, I'm just calling the one that's already loaded into memory, the old one for before I changed it. So in order to get the new version, I need to actually remove the module, and this time I give the name of the module, not the file name, but just the actual name of the module. And then I can import the module again. Import module primes. And then when I say get primes, it's going to give me 2, 3, 5, 7, 11. Okay, we're going to be doing this over and over again. So I'm going to write a little mini function I'm going to call it reload, function reload. And all it's going to do is remove module primes and import module primes .psm1. So the semicolon here is just so I can have two statements on the same line. So it just separates two statements on the same line. Okay. So now when I say reload, I'm just removing the module and importing it again. So this is just for convenience as we're editing our module. Okay. So let's continue. Let's go back to our script here. Now we're going to implement, for get primes, we're going to implement our Sieve of Eratosthenes algorithm. And we need our piece of paper. Remember, we needed to have someplace we're going to cross off the numbers that we've eliminated as being non-primes. So I'm just going to create an array, but instead of an array of Boolean, array of integers, there's actually a type in the .NET framework class library called a bit array. And this is just a very, if all we need to store is Booleans, which can only be 0 or 1, or true or false, then a very compact way of doing that is just to actually save 1 bit for each of those values. So the bit array class is a way that we can create an array that has just 1 bit for each value. So to do this, you can look up bit array I can look up system.collections.bit array. And we see that there's this bit array class. So all these classes that are part of the .NET framework are documented online. And we see that there's a class called bit array, and we see an example here of creating a bit array, so new bit array 5. So this example is written in C#. In PowerShell, our syntax will be a little different. But a bit array has what's called a constructor. So when we create a new bit array, we need to pass in a value to the constructor. And so there's different constructors depending on how we're going to do it. What we want to do is we want to initialize a bit array that just contains a specified number of values. So we just pass in a number, and it can create a bit array of that size. So we're going to end up invoking this constructor, the bit array that takes an int32 length. Okay, so let's go ahead and minimize that. So to create an instance of a class, a new object in PowerShell, we just use the new object commandlet. So I'm just going to call the class numbers, and I'm going to say is equal to new object. So I'm invoking the new object commandlet, and as you can see from the little help thing that pops up, I give it the name of the type I'm going to create. Now the bit array, most of the types we've used so far, like int32 and so on, are in the system namespace. So types are actually grouped into into what are called namespaces, just a way of organizing types into a hierarchy of names so that it's easier to, well, just so that they're more organized, and also so the names don't conflict with each other. So we're going to create a type, and because it's in the system.collections namespace, and that's not one of the namespaces that PowerShell looks in by default. So we actually have to specify the full namespace path, system.collections.bitArray. And notice that the Visual Studio Code knows that this type exists, so it is actually giving us the option to complete that. And then we give it the, since we're going to invoke the constructor that takes the size of the bit array, we're going to pass that using the argument list. So this is the argument list parameter to the commandlet, to the new object commandlet, is the list of arguments that are going to be passed to the constructor of the object. So in this case, we want to pass the size of the array, which is going to be the maximum value plus 1. Plus 1 because we want to be able to actually use max value as an index. So the size of the array for max value to be a valid index, the size of the array has to be 1 greater than that. So there's our piece of paper, if you will, where we're going to cross things off. Now we're going to just loop over the whole array, starting with 2. So I'm going to use a for loop to do that. I'll say for, and I'll just, for loop variable, I'm just going to call it n. And I'll start with 2 for n equals 2. And then we're going to keep going as long as n is less than or equal to the maximum value. So n less than or equal to, so that's the LE operator, max value. And then after each iteration, we're going to increment n. Okay, so we're going to make one pass through the whole bit array, or excuse me, through the whole sequence of numbers. And we're starting at 2 and going up to and including the maximum value. So now what do we do? Well, remember there are two cases. When we looked at our let's look at our whiteboard here. When we found a number that was like 2 that was not crossed off yet, then we actually need to output that number. In this case, I circled it, but you would output that number, and then we scan ahead, and for every multiple of that number, we cross them off. But if we find a number like 4 that's crossed off already, we just skip over it. So let's go back to our PowerShell module. So whether the number is crossed off, the way we check that is we just look in our numbers array. Numbers, $n. So it behaves like an array. It's a bit array, but it behaves like an array of booleans. And so is n already crossed off, i.e. not prime? If so, skip it. Okay, so we're going to say if this expression, if it's crossed off, then what do we do? Well, to skip it, one way we can do that is we can say continue. So continue is a flow control statement we haven't seen before. So we've used break before. What break does is it breaks out of the loop. So from here we would just go right down to this closing brace and leave the loop. Continue skips the rest of the loop body, but it goes on to the next iteration. So continue, we would jump right up here. We would then increment n. We'd reevaluate this, and then move on to the next iteration, as long as the condition is true. So continue is a way of saying, I want to continue on straight to the next iteration. I want to skip the rest of this iteration. Okay, but if we get down to here, if we get to here, then n is prime. So output it. So write it to the output. So say write output $n. And we could just say $n without the right output, but in this case, I think it's maybe nice to be more explicit about it. Okay, now the next step is we've identified that it's prime. Let's go back to our pen and paper version. We've identified that a number is prime. Then what do we have to do? We actually skip ahead, or we advance by multiples of that number and cross all the other ones out. So let's do that. This is where we use our nested for loop. So within this for loop, we have another for loop. We want to cross out all the multiples of n. Okay, so we need to get all the multiples of n less than or equal to maximum value. So how do we do that? Well, we can say for, and we'll give our loop variable, we'll just call it multiple, and the first multiple of n is going to be simply n plus n, right? So if we're starting at 2, then the multiple, we'd cross out 4, 6, 8, and so on. We're going to keep going as long as multiple is less than or equal to the max value. Somehow I'm mistyping the L. I do that a lot. And then each iteration, we're advancing by multiples. So like if n is 2, we're going to go to 4, and then 6, and then 8. If n is 3, we're going to go to 6, 9, and 12. So each time we're going to add n to the multiple. So multiple plus equals n. Okay? And then we just cross out the number. And the way we cross out the number is by setting that element of the number's bit array to true. By the way, all the bit array elements are initialized to false to begin with. So this is create our piece of paper where we cross out non-primes. Iterate over all the numbers from 2, numbers from 2 to the max value. Okay, so this should do what we want. Let's go ahead and give it a try. Let's switch back to our PowerShell prompt, and let's call reload. Because we've just modified our script, our module, we have to reload it for our modifications to be recognized, and we'll call get primes, and I'll pass primes up to 50, say. And this looks like it's doing what we want. So 2 and 3 and 5 and 7, 11, 13, these are all primes up to and including 50. Of course, 50 itself is not prime. Okay, so there's our get primes implementation. What happens if we don't pass an argument? Okay, it just doesn't return anything, so it's defaulting to 0. I think we could declare that to be required, but I think it's okay just to let it be 0 in this case. Okay, so we have our get primes implementation. The next function I want to implement is called factor, or get factors. This will take a number and it will return all of its prime factors. And this will give us an opportunity. So first I'll just do a simple implementation, and then we'll have an opportunity to improve it a little bit by adding some other stuff. But let's start with a simple one. Function get factors. This is going to also take one parameter, which is just the value that we're getting the factors of. So remember, for factoring a number, let's say we have a number like 10, the prime factors are 2 and 5. So we need to find all of the prime numbers that will divide evenly into the number we're looking for. So we can actually start by using our get primes method to get the prime numbers that we could potentially divide into value. Oops. So let's start there. We'll create a value called, first of all, we know that no number could divide into value that's greater than the square root of value, right? For example, if value is 100, the largest possible factor of 100 would be 10, because 10 squared is 100. But 11 times, well, okay, that's not exactly true. We can stop iterating on our loop. So 11, there could be a number like 20 that divides into 100, but there's always going to be a smaller number that's multiplied by to get into to do that multiplication. So we can stop our loop when we get to the square root of value. So let's create a max factor value, and we're just going to assign it. We're going to make it an int, and we're going to assign it to be the square root of the value. So we can use this math class that has a bunch of static methods. So again, we can refer to a class name. The class has some static methods that we can call. We put the class name in square brackets. We use colon, colon. And notice that the math class has a bunch of properties like pi and e that are special numbers. And it also has some methods like square root, sqrt. So square root of value. Okay, that's going to be our maximum factor. So once we have our maximum factor, we can get all the prime numbers that are less than or equal to that. So we'll say primes equals get primes max factor. Okay, so this is using the method we wrote above. Now we can just loop over all those primes to see which ones divide evenly into the value. So for each, so here's an example to write a for each loop, and we'll call this number prime, may or may not be a factor of value, in primes. So our loop variable now is prime, and we want to see if prime divides evenly into value. In order to do that, we can use the modulo operator. So we say if value modulo prime is equal to 0. So modulo just means if you divide two integers, like if you divide, for example, 10 by 3, 3 goes into 10 3 times with a remainder of 1. Well, that remainder is the modulo. So the percent symbol is the modulo operator, and it's basically the remainder. Okay, so if the remainder is 0, it means that the value divided evenly into, the prime divided evenly into value. So in that case, we want to, let's just output the number. So we can, let's add a comment first of all. Does prime divide, or we'll say is value evenly divisible by prime. Okay, so then we'll write output prime. Prime is a factor. And then since we've factored out prime, we should divide value by prime because we've already accounted for that factor. So we'll say value, and we'll divide it. You can say value divided by prime, but we want to store the resultant value, so we're going to say value divided equals prime. So value equals value divided by prime. Okay, I won't bother writing a comment there. Okay, now what if something divides into it more than once? For example, let's say that we have the number 20, and you divide 20 by 2. 2 goes evenly into 20, and that gives us 10. But then 2 goes into 20 again, which gives us 5. So we actually need to factor 2 out of 20 more than once. So let's make this, instead of an if loop, instead of an if statement, let's make it a while loop. Okay. And then when we get to the very end, we might still have, let's say that we call get factors of 101, which is a prime number. We'd count up through all the primes, and we still nothing would have factored out of it. We'd be left with 101. So if what we're left with is still not, if we factored out everything, then we might be left with 1. But if we're not left with 1, we still have that 1 number left that we have to account for. So we'll say if value, the remaining value, is not equal to 1, then write output value. Okay, so let's go back to our, let's clear the screen, reload. Okay, get factors. Get factors of, let's say 100. And we have 2 times 2 times 5 times 5, which makes sense because 100 is what, 4 times 25, or you can think of it as 2 times 5 is 10 times 10. So 2 times 2 times 5 times 5. Let's try get factors 101, like I said earlier. Yeah, that's 101 is prime, so the only factor is itself. Let's try another number. Let's say n is equal to 3 times 5 times 7 times 9 times 11. Okay, so n is 1,395. Get factors of n. Pardon me. Well, let's see. 9 is actually 3 times 3. So this is really 3 times 3 times 3 times 3 times 5 times 7 times 11. So that's what we got. So this is giving the correct result. But maybe it's not exactly the form we want. We have 3, 3, 3. Maybe we'd like to write it as 3 to the third. But let's get to that later. Let's try one other thing. Maybe we'd like to format this instead of, so this, right now this is returning an array, right? We have we say factors equals get factors of n. And this is nice because we can say factors dot length. And we see that there are 6 factors. We say factors 0 to access the individual members. So if we actually are writing some code that wants to call this function, get the factors back, and then do something with it, having it back in the form of an array rather than just a string, having it as an array of integers, is very useful. That's one thing that's nice about PowerShell returning objects and arrays and things like that rather than just strings. But let's say we do want to display it. We might want to have it in a nicer form than that. But we can say something like factors. We can pipe the output of this array to the join. Let's see now. It's the join string, I think it is. Join string. And we can also have a separator in there. So we can say separate it by a multiplication space, multiply space. So there we go. That's kind of nice. So if we want to write factors as this, we can get factors as an array by calling this method. And then if we want to format it as a string, we're saying, okay, we multiply these numbers together to get our original number. Okay, that's kind of cool. Let's try something else. Let's say that we don't want to just have 3, 3, 3. We want to have 3 to the third. Well, we can change our getFactors method so that instead of just returning, so it handles that case, instead of just returning an array of integers, it returns an array of objects, where each object is a factor object that has a base and an exponent. And then we can do stuff with that. So let's go ahead and we have to declare, this is going to be a new type of object. We've seen like file info objects and all sorts of other objects that we've used that have been provided for us by PowerShell, by their PowerShell commandlets. We're going to create our own type of object. And to do that, we're going to use the class keyword. So we're going to say class, and we're going to call our object a factor object. And it's going to have 2 fields or member variables, 2 variables that are properties of this object. And we declare the type like so, and we declare the name like so. So it's going to have a base, which is an integer, base, and it's going to have another integer, which is called exponent. And this is just like declaring a variable. We're giving it a type, and we're giving the name with a $sign in front because it's a variable. Okay, and then we can start with just that. Okay, so now when we go down to here, instead of writing the output, writing the number as the output, we're going to create a factor object. We do have to do something a little different, because if we have, for example, in the case where we're dealing with 100 and we're dividing 2 into it, we're not going to be returning, so 2 goes into 100, 2 times 2 is, or 100 divided by 2 is 50, which then can be divided again as to 25. So 2 is going to go into 100 twice. We're not going to write 2 factor objects out. We're going to write just 1 factor object out, which is going to have a base of 2 and an exponent of 2. So we're going to change this back to an if. And then we're going to have another step to determine the exponent. So first of all, we're going to initialize exponent to 1. We know exponent is equal to 1. And we're going to divide value by the prime number. And then we want to see how many more times value divides into exponent. So wow value modulo prime is equal to 0. Then we're going to add 1 to the exponent. Oops, DQ. Then we're going to add 1 to the exponent. And we're going to divide the value by prime again. So we assume initially that we know prime goes into value at least once. And then we can say how many more times does prime go into value. So we're going to loop repeatedly. As long as prime divides into value, we're going to keep dividing value by prime and incrementing the exponent. And then once we've divided value by prime as many times as we can, so for example, we started with 100 and prime is 2, we'll find that 100 divides evenly, is divisible by 2, so we'll set the exponent to 1, divide it, make it 50, and then it's still divisible by 2, 50 is divisible by 2, so we'll increment the exponent to 2, divide it again, now we have 25. And then it's no longer divisible by 2, so we're going to fall out of the loop. Okay, so at this point we have the prime number, which is the base, and we have the exponent, which is the exponent, of course. We no longer need to divide the value by prime. So now we need to create our factor object. So we'll just call it factor equals new object type name. So remember how before we created we created our system collections Bitarray class from the .NET runtime, and we use the argument class to invoke the constructor, argument list to invoke the constructor. But we created a Bitarray class. Well, we can do the same thing here, only now we're going to create our own class, which is factor. And then we can set the fields that we have, the two fields we defined, the two properties. Factor dot base is equal to the prime number, and factor dot exponent is equal to exponent. And then that factor then is part of our output. So we'll write output factor. So instead of writing an integer to the output, we're writing our factor object to the output. And then down here we have to do something similar. If we have a number greater than 1 at the end, then we're going to be creating a factor object, and in this case the base is going to be the value, the remaining value of the object, and the exponent is going to be 1. Okay, so let's go back to our PowerShell prompt. We'll reload. And now let's call, remember we have our value n, which is the product of 3 times 3 times 3 times 5 times 7 times 11. So let's call get factors n. And this time we have this array of objects, and they have base and exponent properties, and so it ends up being formatted as a nice table for us. So we have 3 to the third times 5 times 5 to the first times 7 to the first times 11 to the first. Well, that's pretty cool. And we can, of course, if we say factors equals get factors sign in factors dot length is going to give us 4 because there are 4 bases, 4 unique prime numbers that factor into this. And then if we say factors 0 dot exponent, it's 3, and factors 0 dot base is 3. So we can refer to the properties of that object. Okay. What if we want to do the join string thing like we did before? Let's copy that. Take factors, join string. Oh, that doesn't give us anything very interesting. Factors, 0. Format as a table. What if we try to convert that to a string? It just comes out as the type name. So the string is just the type name. Well, that's not very useful. I think we'd like to do better than that, but we can. So whenever an object gets converted to a string, the way that works is it looks for a method on that object called toString that returns a string. And if you haven't defined a method, then there's one that's provided for you automatically that simply returns the object's type, which in this case is factor. But we can actually define our own toString method. And to do that, we give it a type. The type in this case is the return type of the method. So this is the type that's returned or output by the method. And for toString, we're expecting it, of course, to return a string. And then we give it the name. And then we give it the parameters inside of parentheses. toString doesn't take any parameters. So that's what distinguishes this from a property like this, from a field or property, is that it has parentheses and then it has the curly braces, and so this is a method. Okay, so to return our string, let's just start by returning the base. Okay, we can do better than that, but just to see that this is actually working. And we actually do have to use in a method, if it returns a value, returns like this does, you notice that if I hover over this, variable is not assigned. The other thing is actually within the method, to refer to the properties of this object, we have this magic variable called this. So just like when you have the $_ as a pipeline variable in some cases, here we have a special this variable that refers to the object that the toString method was invoked on. So when you call toString on some object, then within that method, this refers to that object. So then we can say this.base. So let's actually just return the base. Of course, in order to do this, we have to enclose this whole thing. We have to close this whole thing in $ left parenthesis and then right parenthesis. Okay, so when this gets expanded, then inside the $ left parenthesis, right parenthesis is an expression. We'll evaluate this expression and convert it to a string, and that will be what we return. And we do have to actually use the return keyword here. When we're returning from the method, we have to actually use the return keyword. Okay, so let's reload this, and we'll again call factors. We'll call get factors and assign the result here. We'll call factors 0, and we'll just call toString directly. And we see that it's 3. And likewise, if I try to convert this to a string, factors 0, it's going to give us that string. So that's pretty good progress. We have our conversion to a string working. It's still not working quite correctly, however, because we're only writing the base, not the exponent. So we didn't fully implement it. We just made it so that it returns something. Let's actually have it do the right thing now. So if the exponent is 1, then returning just the base number is fine. But if the exponent is greater than 1, we should return something else that that's like the base raised to the exponent. So this is going to be a conditional. We can use the ternary operator again, the question mark operator. So if this dot exponent is equal to 1, then we can just return the base like we did before. Let me copy that. Otherwise, we use the colon again. So before the colon is what to return if this, oops, that's not a question mark. If this Boolean expression is true. After the colon is what to return if the Boolean expression is false. And in that case, we'll return the base And then we'll just use a caret. It's not an actual operator in PowerShell, but it's we'll use it to represent an exponent, and we'll parentheses. We'll then say, so this is inside these $ parentheses. We'll have the expression we're going to return, which is this dot exponent. Okay, let's try this again. We'll say reload, and let's again call our getFactors method, and then factors. So the first factor has a base, factor 0 has a base of 3 and exponent of 3. Let's see what the string, when we convert that to a string, what do we get? String factors 0, and now we get 3 exponent 3. Whereas for factors 1, if we convert that to a string, or equivalently if we just call factors 1 dot to string, oops, left off the $, to string, we get just the base. So the syntax of calling a method is, we have the expression on the left is the returns whatever object we're going to call the method on. We have a dot, we have the method name, and then any parameters go inside of parentheses. So it's a little different than invoking a command, because we do put the parameters in parentheses. Okay, so that's a fully functioning implementation of a class. We could do one more thing to improve it. Down here, when we create the class, we knew the object, we call new object to create the object, and then we have to afterwards set the base and the exponent members. That's a bit different than what we did up here when we created the bit array. In that case, we were able to pass a parameter to a constructor, which created a bit array of the desired size. So in this case, wouldn't it be nice if we could specify the base and the exponent right in the statement where we create the object? We can do that. What we need to do is add a special method called a constructor. And the constructor is, what identifies it as a constructor is that it has the same name as the class itself. So we just say factor, and then we get whatever parameters we want to the constructor. In this case, we're going to have a base and an exponent. And otherwise, it's just the same as any other method. And again, to refer to members of the object, we have to use the this variable. So we say this dot base, referring to the base property of this object, is equal to the base parameter, and this dot exponent is equal to the exponent parameter. Okay, so now down here, when we knew the object, we can just say argument list prime exponent, and then we don't need these anymore. And down here, we can do the same thing. We can say, and in fact, we can just combine this all into one statement. Write output and likewise down here, we can write output new object type name factor argument list. Oops, not quite sure. Argument list. And in this case, the argument was value, and the exponent was always 1 in this particular case. I'm just going to include this whole, put parentheses around the whole thing. Now we don't need that. So we can put it all in one line, makes it a little bit more concise. So let's try this one more time, just to make sure that actually works the way we expect. Reload, and let's again call getFactors and assign the result to our factors variable. And if we look at the result, we have the base and exponent of what we expect. We have 3 to the third times 5 times 7 times 11 gives us 10,395. And of course, we can convert that to a string by calling factors join string separator And now we have 3 to the third times 5 times 7 times 11. And this works because when each element of the array gets converted to a string before being joined, it's invoking our toString method, which is giving us these 3 to the third, 5, 7, and 11. Now here we have this there's one more thing I can show you. Here we're passing a value and 1, even though the exponent in this case is 1. What if we wanted to be able to make it a little bit more convenient to create a factor object from a value, from just simply a value without specifying the exponent? We just wanted the exponent to be 1. Well, we can create more than one constructor. So we can create as long as they have different numbers of arguments, or as long as the arguments can be distinguished, we can create a factor from just a single value. And by the way, here we can declare the types if we want. So this can be an int, this can be an int, and here we're going to create a factor with just an int. But in this case, only a single value is specified, so we're going to say this dot base equals that value, and this dot exponent equals 1. So this is called overloading because we have more than one method of the same name, and that can be used for constructors or for other methods as well, as long as we can distinguish between them based on the parameters. So in this case, when we create the object, we're passing two values, the prime and the exponent. We're passing two arguments to the constructor, so it's going to pick the constructor that has two arguments, and that's the one it's going to use to initialize the object. And then down here, we can simply eliminate the comma 1. We can simply pass the single value as the argument list, and then when it invokes the constructor, it's going to find the constructor that takes just that one argument, and that's the one it's going to use. So let's reload and do this one more time, and then we'll go back and review the program, and then to summarize what we've learned. So, whoops. So we call get factors again, and as expected, we have the same results we did last time in the cases where if we say get factors 101, then it's definitely the case that we're using that last line to initialize the factors object in that last time, because 101 is prime, and so we did not factor anything out of 101. So it did in fact set the exponent to 1 the way we expect by invoking this other overloaded constructor. Okay, so let's go back. So we created a PowerShell module just by creating a file with a PSM1 extension, and we can load the module simply by calling import module and the name of the module. And then when we want to unload the module, we can call remove module. And this time we just give it the name of the module, which is the same as the base name of the file. And now the module is no longer loaded. So if I call get factors, it doesn't find it. So this module has a function called getPrimes, and it implements the Sieve of Eratosthenes algorithm to find all the prime numbers less than or equal to this maximum value. And it does so by process of elimination. So first we create our piece of paper as a bit array. So the size of the array is the so the arguments passed to the Bitarray constructor are the parameter to arguments list. In this case, we're invoking the Bitarray constructor, which we could find by online help by searching the web. The Bitarray constructor that takes an integer as an argument creates a bit array of that size. So we're creating a bit array of size max value plus 1, and we assign that to our numbers variable. Then we're going to use that to keep track of which numbers we've crossed off as not being prime. So initially none of them have crossed off, they're all false, and as we cross off numbers, we'll set those to true. Now we just loop over all the numbers from 2 up to and including our maximum value. So we use a for loop for that. Set our loop variable, initialize our loop variable to 2. This is our init expression where we initialize the loop variable to 2. We keep looping as long as our loop variable is less than or equal to the maximum value. So this is our condition expression. And then as our increment expression, at the end of each loop iteration, we simply increment our loop variable. Okay, then within that outer loop, we check if we've already crossed off the number. If we have, if it's not prime, then the value at that index in the bit array is going to be true. In that case, we just continue, which means we skip the rest of the current iteration and continue on, straight on to the next iteration. We do still, when we do that, we do still evaluate the increment expression specified by the for loop. But if the number is prime, then it will not have been crossed off, and we fall down to here. In that case, we write the number to the output, so the output will include that number because it's prime. And then we still need to, we then go and check, we have a nested for loop, a for loop within our outer for loop. We're going to consider all the multiples of that number less than or equal to the maximum value. So we start with our prime number plus itself, so times 2. And then as long as our multiple is less than or equal to the max value, we're going to keep looping. And then for each iteration, we're going to advance, we're going to step by that number, by the prime number. So if it's 2, for example, we'll start with 2 plus 2 is 4. We'll loop as long as our multiple is less than the maximum value. Let's say it's 100. We'll loop as long as our maximum value, or our multiple is less than 100. And after each iteration, we'll add 2. So we'll go from 2 to 4 to 8, or 2 to 4 to 6 to 8 to 10, etc., until we get to 100, until we get past 100. And then we'd simply mark that number, since we know it's a multiple of our prime number, we mark that as true in our bit array. When we get to the end of this for loop, we just fall through, we come down to this closing brace, and we just pick up where we left off. Now we're at this closing brace, we go back up to the next iteration of our outer loop. So if n was 2 before, now it's going to be 3. And so on. And we do this until we get all the way through the whole thing. Now there are certainly ways that we could make this more efficient. For example, we know that the only even number that's going to be prime is 2. So we could have maybe saved some time and space by not even storing the even numbers, only storing the odd numbers. But I was just trying to make the simplest version of the algorithm that I could do. And it does serve to illustrate the basic concept. Okay, so then we have our factoring algorithm implemented by the getFactors class. And initially we just returned an array of numbers, an array of integers, by writing multiple integers to the output. But the problem we had with that was that, for example, if the result was 2 times 2 times 3, for example, which would be 12, then if we factored 12, we would write out 2, 2, 3, whereas we thought it would be nicer to be able to write 2 to the third times 3. So instead of returning an array of integers, where we'd return the same base integer more than once, we return now an array of factor objects. So we defined our own type which is defined by our factor class. We use the class keyword. We give it a name. We give it properties. Each property has a type and a name. And then we also gave it methods. So there's the special kind of method, which is the constructor, has the same name as the class and no return type. And it takes parameters and allows us to initialize, set the initial values of the object. Within the constructor or any other method, this variable is a special variable that means whatever object the method is being invoked on. We have 2 constructors because we can call this with either a single value, in which case it has exponent 1, or with a base value and an exponent, in which case we set both numbers. In addition, we define the toString method, because the toString method is what is invoked if our object is converted to a string, such as when we wanted to join the string. But we didn't want it to look like this. We wanted it to look like, where did we find the right one? Like this. So when our object, in order to convert our object to the string, we could actually write our own code that instead of just returning the type name, which is the default behavior, we can do something sensible based on what the properties of that object are. So the getFactors method or function that we defined takes a value and factors it by simply checking which prime numbers divide evenly into the value that's specified. And each time we find one that divides evenly, we use the modulo operator to check that. If it divides evenly, then the modulo, which is the remainder, will be 0. So if you find one like that, then we divide the number out, and we keep doing so until it no longer divides evenly. And each time we divide it out, we increment the exponent. When we've done, then we create an instance of our factor class by calling the new object command. We give it our type, and we give our argument list, these being the values that are passed to the constructor. And that is it. So we've learned about creating a module, having methods that we can call in that module, and also defining our own class, which is a type of our own type of object that with its own properties and its own methods. So thank you for watching. I hope you enjoyed this, and I hope to see you next time. Thanks.